Look up at the night sky on the clearest, darkest night you can imagine. You'll see the bright streak of the Milky Way, maybe even pick out the faint glow of Andromeda if you know where to look. But there's something else up there. A quiet neighbor almost no one talks about. It's smaller, softer, and far less famous. Yet it's hiding something that challenges one of astronomy's biggest assumptions. If you could stand under skies untouched by city lights, you might spot it. A tiny, hazy patch floating just beyond a trio of stars that form a neat triangle. At first glance, you'd mistake it for a distant cloud. But it isn't a cloud at all. It's the combined light of tens of billions of suns, each one spinning in a graceful spiral more than 2.7 million light-years away. Astronomers call it the Triangulum Galaxy, or M33. Think of it as the Milky Way's smaller cousin, about half the diameter, with only a tenth as many stars, but with a personality that makes it stand out in a crowd of over 50 galaxies in our local group. What makes it irresistible to scientists is how open it is to observation. From Earth, we see it almost perfectly face-on, its structure spread out like a map. No thick dust lanes blocking the view, no twisted core from violent collisions. Just a clean, intricate spiral where star formation is happening in full display. In many ways, it's the ultimate laboratory for studying how galaxies grow, change, and interact with their neighbors. But here's the twist. When astronomers peer deep into its heart, they don't find what they expect. Most spiral galaxies, including our Milky Way, have a colossal black hole in their center, an anchor of gravity shaping the motion of everything around it. M33? It breaks the pattern. There's no supermassive black hole lurking in the middle. Instead, its core glows with clouds of energized gas, a luminous heart without the heavyweight engine we thought was essential. This is where our journey begins, with a neighbor that follows its own rules, refuses to fit the mold, and dares us to question what we thought we knew about the very nature of galaxies. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. The Triangulum Galaxy didn't get its name from astronomers sitting in a lab, but from the way it quietly hangs near the small constellation called Triangulum in the northern sky. The three stars form a perfect geometric shape, and just off to the side, barely visible to the naked eye, lies this faint swirl of light. For most of human history, nobody noticed it at all. Ancient stargazers who tracked planets and mapped constellations never recorded its presence, and for good reason. You need almost impossibly dark skies to even guess it's there. It wasn't until the invention of the telescope, in the 17th century, that an Italian astronomer, Giovanni Battista Hodierna, scribbled a note about a cloud-like object floating near the triangle. Decades later, Charles Messier would add it to his now famous catalog as object number 33, placing it right next to another spiral beauty, Andromeda M31. Back then, nobody knew these spiral nebulae were entire galaxies, far beyond the Milky Way. The idea was almost unthinkable, that the universe was far bigger than the stars we could see. It wasn't until the 1920s, when Edwin Hubble and others proved these were separate island universes, that M33 was truly recognized for what it was, a full-fledged galaxy, 60,000 light-years across, home to about 40 billion stars. That's modest by galactic standards, but size doesn't tell the whole story. What makes M33 fascinating is how pristine it is. Seen from Earth, it tilts just enough, about 54 degrees, to reveal its spiraling arms without hiding them behind thick dust. Unlike many of its cousins, it doesn't have a central bar structure. Its spiral arms unfurl directly from the core, loose and elegant, branching into smaller arms that wind outward like ripples on a pond. This gives M33 a softer, more open appearance than galaxies with tightly wound arms. It's the sort of shape that makes astrophotographers stay up all night chasing that one perfect exposure, because every detail is out there, free to be studied. And M33's arms are far from empty. They are packed with regions where stars are being born at a staggering pace. Strangely, its northern and southern halves behave differently. The southern side glitters with hot blue stars, young, short-lived giants that shine fiercely before burning out in dramatic explosions. The northern side, in contrast, glows with the light of massive clouds of ionized gas dotted with emission nebulae, where intense ultraviolet radiation strips electrons from hydrogen atoms. This split personality isn't just beautiful. It's a clue to the galaxy's past interactions, perhaps shaped by gravitational nudges from nearby Andromeda. Astronomers have spotted only a couple of small companion galaxies around M33, and even those are questionable. They might belong to Andromeda instead. That's unusual. Most large galaxies are surrounded by a swarm of smaller satellites, their shapes tugged and twisted by their parent's gravity. M33, on the other hand, seems to live a relatively undisturbed life. That lack of external interference could explain why its spiral arms remain so neat and why it's such a perfect example for studying star formation without the chaos of recent collisions. Yet, despite this peaceful exterior, M33 is not static. Gas continues to flow into the galaxy, fueling its star factories. Clusters of young stars flare to life, sending out stellar winds that carve cavities in the surrounding gas clouds. When you realize that this entire process is happening 2.7 million light-years away, and that the light you see left those stars when early humans were just beginning to walk the Earth, it's hard not to feel a connection. It's like peering into a family album, only the pictures are millions of years old. The more you learn about M33, the more it feels like a paradox. Small but significant, calm but bursting with energy, close enough to study in detail, yet still holding back its deepest secrets. And in those secrets lies the key to understanding why this unassuming neighbor might be one of the most important galaxies we've ever studied. If the graceful spiral arms of M33 are the stage, then its star-forming regions are the fireworks show, and nothing steals the spotlight quite like NGC 604. From our vantage point, it looks like a glowing patch embedded in the galaxy's northern arm, but that's like calling the Grand Canyon a ditch. In reality, NGC 604 is over 1,500 light-years across, more than 40 times the size of the famous Orion Nebula, and if it sat where Orion does in our sky, it would outshine every other object at night, except the moon itself. Imagine looking up and seeing a patch of light so bright and vast, you could mistake it for a second sunrise frozen in place. Inside this stellar nursery, more than 200 massive blue stars and Wolf-Rayet stars pour out ultraviolet radiation powerful enough to strip electrons from the hydrogen gas around them, turning the entire cloud into a glowing plasma. Wolf-Rayet stars are like the rock stars of the cosmos, burning at over 30,000 Kelvin, shedding mass through intense stellar winds, and living fast before ending in spectacular supernovae. The energy they release carves cavities in the nebula, creating vast bubbles of hot plasma, each one millions of degrees. It's a violent beauty, the kind that reminds you the universe is both an artist and an engineer. But NGC 604 is just one highlight. Across M33, the Spitzer Space Telescope has spotted more than 500 infrared bright sources, most of them massive star-forming clouds. Some lie at the edges of the galaxy, like cosmic suburbs where new generations are just moving in. Others cluster near the core. And that's where things get strange. Because when you zoom into the center of M33, you expect to see what almost every other large spiral galaxy has: a supermassive black hole. In the Milky Way, that central engine weighs over 4 million suns. In Andromeda, it's closer to 100 million. These cosmic anchors shape the orbits of stars, regulate gas flows, and may even influence how often new stars are born. But in M33, the seat of power is empty. Instead of a dense, star-packed bulge and a dark gravitational monster at the middle, M33's core glows with yet another star-forming region. Clouds of ionized gas lit by young stars and something astronomers call an ultra-luminous X-ray source. That X-ray source might be a medium-sized black hole, but if it is, it's tiny by galactic standards. Perhaps a few thousand solar masses at most. That's so small, we'd expect to find something similar in a massive star cluster, not running the center of an entire galaxy. It's as if a city the size of Chicago was run not by a sprawling government, but by a single neighborhood council. This absence is more than just a curiosity, it's a puzzle. Does M33 prove that a galaxy can grow and thrive without a supermassive black hole? Or is it hiding one so small and so quiet that our instruments simply can't detect it yet? Either answer forces astronomers to rethink the rules we've written about galactic evolution. And then, tucked away in M33's outer regions, there's another surprise. M33X7, an X-ray beacon that pulses every 3.5 days as a black hole passes in front of its companion star. This isn't just any black hole, it's the heaviest known to have formed from the collapse of a single star, weighing in at nearly 16 times the mass of the Sun. Its companion is no slouch either, a blue giant 70 times the Sun's mass, locked in a deadly orbital dance. Every time the black hole passes, it siphons off a bit of its partner's matter, heating it to millions of degrees and unleashing powerful X-rays we can detect across millions of light years. Put all of this together, the titanic power of NGC 604, the hundreds of hidden stellar nurseries, the record-setting black hole in the outskirts, and the baffling absence of a heavyweight at the center, and you start to see M33 for what it truly is: a rule breaker, a galaxy that refuses to fit the patterns we thought were universal. And like any great mystery, the more we study it, the more it reminds us that the universe doesn't owe us easy answers. It owes us wonder. For all its calm elegance, M33 isn't living in isolation. It's part of a crowded neighborhood, the local group, and its fate is tied to the motions of its larger companions. One of those companions, Andromeda, looms just 750,000 light-years away, a staggering distance by human standards, but a short walk in cosmic terms. Between the two galaxies, astronomers have traced a faint bridge of hydrogen gas, like a ghostly thread connecting their destinies. This bridge tells us they've already brushed past each other once in the last few billion years, and that gentle encounter may have stirred some of the star-forming activity we see in M33 today. But that was only a prelude. The real drama is still ahead. Measurements of M33's motion show it's drifting toward us at about 24 kilometers per second, not a straight beeline to Earth, but part of a larger gravitational ballet involving the Milky Way, Andromeda, and dozens of smaller galaxies. And we already know the main event. In about 4 billion years, the Milky Way and Andromeda will collide head-on, their graceful spirals shredded and reshaped into a single giant elliptical galaxy. Where does M33 fit into this grand collision? That's where the speculation gets exciting. One scenario says M33 could fall into Andromeda before the Big Impact, pulled apart by its larger neighbor's gravity. Its stars would be scattered into Andromeda's halo, their light mixing with billions of others until no trace of the original spiral remained. Another possibility is that it survives the initial clash, slipping into orbit around the newly merged galaxy like a wary moon around a planet. In that case, it might live on for tens of billions of years, slowly losing stars and gas to its giant host, but still recognizable for an incredibly long time. And then there's the wild card, a gravitational slingshot. If the timing and angles are just right, The collision between Andromeda and the Milky Way could fling M33 out of the local group entirely, sending it coasting into deep intergalactic space. At first, that sounds almost liberating, a chance to avoid the chaos of galactic mergers. But drifting alone has its own cost. Without the tidal nudges and fresh gas that interactions provide, M33's star factories would eventually run out of fuel. Its bright, young stars would age, fade, and be replaced by cooler, dimmer populations, and over unthinkable spans of time, the galaxy would slowly lose its brilliance. It wouldn't vanish, but it would grow quieter, its spiral arms less defined, its light dimming until only the most powerful telescopes could find it. What makes all of this so captivating isn't just the fate of M33, but what its story tells us about galaxy evolution in general. By studying its structure now, before the next big chapter in its history begins, we get a rare snapshot of a spiral galaxy in a relatively undisturbed state. That makes M33 an invaluable reference point when we try to understand how collisions, mergers, and environment shape galaxies over billions of years. It's like finding a photograph of a bustling city before a major transformation, a picture you know will be priceless once the landscape changes forever. Whatever path M33 takes, whether it's torn apart by Andromeda, captured as a long-term companion, or flung into the wilderness between galaxies, the stars within it have time. Even on the shortest timelines, we're talking billions of years before its spiral arms are altered beyond recognition. That means any story unfolding inside M33 right now still has room to play out, uninterrupted, under skies lit by some of the most spectacular star-forming regions in the local group. And it's here the mind starts to wander. If somewhere in those 40 billion stars there are planets with life, maybe even civilizations with their own sciences, arts, and histories, then right now, as you hear these words, their night sky is shaped by a very different view. They might see our Milky Way as a glowing ribbon, Andromeda looming larger and brighter than we ever will, and their own galaxy as a vibrant home still young at heart. Would they know they're part of this slow-motion dance between giants? Would they have already mapped the invisible hydrogen bridge connecting them to Andromeda? Or maybe they're looking at us, through telescopes of their own design, wondering if any of the tiny points of light in our galaxy harbor someone asking the same questions. That's the quiet beauty of astronomy. It connects us not just to distant places, but to the possibility of distant perspectives. M33, with its missing heart and restless future, reminds us that the universe doesn't follow a single blueprint. Some galaxies grow with colossal anchors at their core. Others, like Triangulum, seem to thrive without them. And perhaps that's the lesson it offers, that there's no single way to shine, no fixed rule for what a galaxy or a civilization must be. Out there, under skies we'll never see in person, the light of M33 still travels toward us, carrying not just the story of a galaxy, but the invitation to imagine our place among billions of others. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH. If this journey made you think, feel, or simply wonder, please consider subscribing to support the channel. There are more questions waiting, and together, we'll keep searching.